So we can describe these scatter plots using our visual interpretation, whether it has a positive or a negative relationship and how strong it seems to fit on a line. But because we don't want to simply rely on somebody's interpretation of what they see, we have a numerical description that we use to describe that strength and the direction of a scatter plot, and that is called the correlation. So we are looking at these straight line patterns specifically because these straight lines are often common in a lot of the variables that we have. So the correlation is only used to describe these straight line relations, and we're going to describe them as being strong if the points are close to a straight line, but weak if they're widely scattered about that line. So it's interesting to see these two graphs because these actually represent the exact same values. It's just the scales have been adjusted. The one on the left has been zoomed in, the one on the right has been zoomed out. And so it looks like the one on the right is actually a lot stronger because they're grouped together. But we do have to be careful that we are considering the scales here when we're making our interpretations. If there's an awful lot of blank space around a cloud in our scatter plot, then we would need to be able to have some additional calculations to help us understand exactly what's going on in the scatter plot. And so that's why we rely on this idea of correlation as a numerical measure to describe the direction and strength of our straight line relationship. It's usually given the letter R, and calculating the correlation is quite difficult, but we're going to be using Crunchit in order to calculate the correlation for data. So if you have a positive correlation value, then that means that there's a positive association between the variables. If your R is negative, then that means that you're looking at a negative association. So a few things about correlation. It's always going to be a value between -1 and 1. So if you have a value for correlation that's outside that range, something went wrong. Values that are near 0, that means that there's a very weak straight line relationship. But as you move towards -1 or 1, the strength is increasing. So the closer you are to -1 or +1 means the closer those points are lying on a straight line. The only time that you'll have exactly -1 or +1 is when the scatter plot is exactly on a straight line. So +1 and -1 both indicate the same relative strength. It's just they're in an opposite direction, whether you have a positive relationship or a negative relationship. Now, R is calculated using standard scores that we talked about in the previous chapter. And so because of that, it actually does not matter if we change the units of our variables, because we're going to be standardizing the scores anyway. So there's actually no unit here either, because we are just looking at the standard scores. Correlation also makes no distinction between which variable is the explanatory and which variable is the response variable. So if you switch your X and your Y, you're not going to change the value for the correlation. Another thing that's super important is the correlation is only giving us the strength of a straight line association. If it's a curved relationship, no matter how strong, the correlation is not going to be measuring that. So it's always important that you look at a scatter plot before you calculate your correlation to make sure that you are looking at a straight line relationship. Also, R is strongly affected by outliers. So you would definitely want to be looking at the scatter plot to determine if there are any outliers before you did this calculation. And then finally, since correlation is measuring the relationship between these two variables, we absolutely have to be looking at two quantitative variables. This does not work for categorical variables. Now, correlation is not a complete description of this two variable data, even if it's a very good straight line relationship. You would always want to give the mean and the standard deviation along with the correlation so that you can provide a full picture of the data.